And hello, welcome to this video. Okay, so the last video I was talking about how classes and namespaces are used to organize functions, and if you have 20 functions, it's good to get them organized by type into a class so that your code is neat. So that maybe when you look at it 5 months down the road, you actually know what's going on, rather than you look at a mess of 20 plus functions or even 10 plus 20 plus classes. So you can organize functions into classes, and you can organize these classes into namespaces. So this is what a namespace and class look like in C#. You will also find an example here in the test page cshtml.cs. So you can see the basic structure here. Namespace, okay, a namespace will be a way you can organize classes, and a class is a way you can organize these functions. So all of these things here are functions and data sets, and you notice that usually we'll have open and close curly braces for your classes, and you can also do open and close curly braces for namespaces as well. This, if you ever use a semicolon for your namespaces, as you see here, this is a semicolon notation for namespaces. You can do that, but and of course it makes your code look neater. But what that means is that if you declare a namespace here, every class that is declared in this file will belong to this namespace. Okay, but if you really want to make things clear and still use curly braces, okay, and you want to say that this class belongs to this namespace, then you use this notation if it's less confusing. Okay, but in C# you will see both of them. So yeah, do take note. All right, so that's for namespaces and classes. Okay, so now let's get our hands dirty and try to build our own class inside a Razor page. Okay, it may of course yeah. So since this is a beginner-ish kind of a way of doing things, I will just tell you straight the answer of how we can do it. All right. So anyway, this is declaring namespaces to organize types. Yes, classes in Razor engine template. So the way to do it is to use the add functions code block, or the keyword, and then you start writing your class. All right. So let's follow this template. All right. Remember, class. The whole idea of a class is to have functions, to group functions together. Okay, so we use the add functions template. So we have to open and close curly brace every time. So with C# or C++ or C family code, you either end with a curly brace or you end with a semicolon. You must end with one or the other. So if you see here, the add code block will end with a curly brace. Add functions ends with a curly brace. When we declare classes, we end with curly braces rather than just semicolons. So either curly braces or semicolons. That's very important. 1, 2, 3, 4. Okay, what class do you want to have? Well, last time I was talking about temperature conversion, so let's call this class temperature conversion. Class temperature temp conversion. All right. So open and close curly brace. So remember, good rule of thumb for C#: always open and close curly brace or semicolon. Okay, so 1, 2, 3, 4. Okay, I can put a function in here. And remember last time we were dealing with lambda functions, so basically I can copy this whole thing. Okay, let me undo that change. Copy this whole thing, yank it, and then I will paste it here. Okay, so 1, 2, 3, 4. So what do we have here? Remember, we have a semicolon in the back, so we are good to go. All right, and that is basically our first class. So what do we have here? We have a class, and then we have a function. I have not gone into namespaces just yet, so because you want to take things one at a time. All right, so remember, a class is a collection of functions and other stuff we put inside. So we want to do it to keep things organized, And how do we use the function within the class? Okay, so the way to do it is you need another Razor code block. So a Razor code block is this @ symbol with curly braces here. Okay, of course in a pure C# file, you won't need to have all these open and close curly braces, because this is in the context of a Razor web page. So it's slightly more complicated than a normal C# file. But anyway, this is how you do it in a Razor web page. So 1, 2, 3, 4. Alright. So this is a code block, and what we are doing here is to declare an object. Okay. So what is object declaration about? Okay. So last time we actually declared functions, and then we use the functions here straight away, right? No problem. So okay, classes are sort of more complicated. You need to declare classes in a similar way of how you declare variables. So how do you declare variables? There are two parts to it. You must first declare the type of variable. For example, this string A, STRA, is the type string, and then you need to assign a value. Okay, the value here is hello, this is test text 1, 2, 3, 4, 5 for string A. For classes, it's the same thing. You need to define the type, and you need to define a value. So let's do, okay, object declaration. Okay, first define the type. Okay, so this is what you're doing. What's the type? Temp conversion. Okay, the class actually counts as a type. Okay, class actually counts as a type of variable. So I will call this object T1. T1 is this variable which is this variable. We just declared the type as temp conversion. So okay, next thing is object declaration. Second, define the value. So remember, we need to give a type, and then we need to give a value. Okay, so type and value. So how do you define the value? So T1 equals to something, right? And then semicolon. So remember, semicolon or curly brace for C#. So T1, how do you define a value? Okay, the value is very simple. Just type the keyword new and then temperature conversion. So the class name with open and close brackets. Okay, so this is how we declare objects. All right, and if we want to do both things in the same line, we can. T2 equals to okay, how do you do both things in the same line? We do the type first, temp conversion T2. So I can declare two objects, meaning to say I declare two variables which are copies of the class. So, or actually the proper term is called instance. Copies is a bit easier to understand than instance. So I'm making two copies of instances of the same class. Alright, so temperature conversion T2 equals new temp conversion. And this is the what you will often see. This is what you will often see in C# code, and it may be very confusing when you see temperature conversion here and temperature conversion here as well. Well, so to make it less confusing, remember what you are doing here. You are giving it the type and you are giving it some value. So that's all you are doing. So next time you see this, just think of these two steps that you are doing in one line. And this also goes to show why why it's good to put comments and tell people what you're doing so that they're not confused. Alright, because when you look at this line of code, people will not always be sure. Okay, and how much more important it is to document your code, make sure people know what you're doing, present things neatly, so that you don't confuse yourself and you don't confuse other people. Alright, so now that we declare an object, how do we then use the object? Okay, to use the object is very simple. Okay, I will just do it like that. Okay, I will just use it like that. Okay, I want to call the function f to c because f to c2 doesn't really make sense here. It's f to c2 because this is our second function. Okay, but over here we can just call it f to c because it just does what it says it does. It turns temperature in Fahrenheit to degrees Celsius. So what do we do? Okay, we just put add. Okay, insert add t1 dot f2c, and then all we need to do is just to have the t1 dot prefix to the front of the function, and then we will be able to execute the function straight away. So what do we need? We need a temperature in degrees Celsius, or in degrees Fahrenheit. Maybe we put 88F and we put it to 1 decimal place. Okay, we'll save it and take a look. We'll reload. Okay, why isn't it reloading? You can go and take a look at .NET Watch. It says unable to apply hot reload because of root edit. Okay, root edit means that something is probably a little off. You're kind of editing the code such that it breaks the page. So let's just restart the app and see what happens. Okay, there's an error here. It says the temperature conversion F to C is inaccessible due to its protection level. Okay, what is this protection level? Yeah, what is this protection level talking about? Well, let's say we let me give you an analogy first. Okay, let me give you an analogy first. Let's say you're surfing the web, and then your operating system has a way for you to connect to Wi-Fi, right? So this application actually helps you connect to Wi-Fi, all right? And this Wi-Fi will let you put in username, password. Okay, username and password. All right, and then it allows you to select the SSID, which is the name of the network. Okay, it's also called SSID. That's the proper name. Okay, so you can think of the application as a function that is taking in these variables, username, password, SSID, and then it helps you to connect to the Wi-Fi. Now, under the hood of this Wi-Fi app, there may be many functions. I don't know how many there are. There are other functions here. There may be other functions here, but let's say if you try messing around with the Wi-Fi function, the other functions in this Wi-Fi app, you will break the code. And then after that, what happens? You will not be able to connect to Wi-Fi if you do something really bad. Okay? So the way that coders want to so-called give you the Wi-Fi app, they only want to give you the function that actually helps you connect to the Wi-Fi. Every other function that works behind the scenes, they don't want to show to you. If not, you might break the whole application, and then you are in trouble. Or rather, you are greatly inconvenienced. You're not really in trouble, you are just very inconvenienced. So these things here, we call them, we like to call them private. Okay, these things here we like to call them private, and these things here, since they are available to you or anyone who uses this Wi-Fi app, we like to call them public. Okay, private means you cannot tinker with it unless you are so-called unless you are using it within the app itself. You're not using it, is not exposed to the rest of us who just want to use this Wi-Fi app. You, as a developer, you can go and tinker with the code, make some edits and updates, but generally speaking, you don't want anyone else to access those functions. If not, it will break everything. But for example, the functions or the classes or whatever that's going on behind the scenes that help you connect to Wi-Fi, you will be able to use those functions, so to speak. You put in your username, your password, your SSID, blah blah blah, and then you will be able to connect. Okay, these are so-called public functions or public classes or whatever. Okay, these are functions that help you connect to the internet or the Wi-Fi. All right. So this is the idea of having why people have public and private functions. Okay, so how does this look like in C#? Okay, in C# you see this public string, public thing before every function, and even classes can be public or private. So you see these keywords here, private and public. So this is exactly what you can do as the coder now. You can define what functions are public and what functions are private. Now if you don't define anything, by default I think the classes will be private. Okay, you will not be able to access it from outside. So you have to explicitly tell C# that it is a public class or public function. So how do you change the function to public? Okay, you just put the public keyword in front. Okay, public, so that everyone can use your class. So as you can see, once you fix this, the hot reload works, and now we are able to turn this into a public function. Okay, so let's do, since classes are supposed to have more than one function, I mean that's what they're there for. You can have a class with just one function, but I don't know why you do that. Okay, I mean in C# usually most of your functions are supposed to be within classes anyhow, except for these lambda functions, which are the simple ones. Okay, so lambda function for Fahrenheit to Celsius, and then let's make another function, and these functions are a bit differently formatted, but the logic is the same. Okay, Celsius to Fahrenheit. Okay, how do functions look like? Well, if you take a look here, functions look like this. They have a public. You need to do a public or private. Then you need a return type. Okay, return type, and then return type, and then this is where you will define the body of your function. And for lambda functions, we have a semicolon in the back. For, I guess these are more normal functions. These are functions you will learn shortly. This will be covered by open and close semi braces. So alright, so let's go back. Okay, so remember lambda functions, we need to tell C# or tell .NET what is the kind of input and output to expect. So how do you say that? Okay, first we do the public. Alright, public, and then we define the output type. So instead of defining your input type first, you define your output type. I want to say the output type is double. After that, then I will we will need to specify the output type, input type as well. So how do we specify the input type? Well, the syntax is a bit different. The way we do it is a bit different. We need to type the name first. C to F. Okay, we call it C to F, and then we have open and close brackets and open and close curly braces. Okay, what is the open and close brackets for? Open and close brackets are for you to put your inputs there. So what are your inputs to this? Well, we will need to give the type and the value. We will need to give type and value. So the type, okay, let's do double temp C. Okay, this is the temperature in degrees Celsius. Okay, so this is very it will make it very clear and explicit which variable you are declaring. And the next variable here, we will need to have a integer, because we want to define the number of decimal places. Okay, so the number of decimal places is here. Alright, the number of decimal places is here. So 1, 2, 3, 4, as always. And then we need to define the return type. Okay, or the output type. Usually to tell C# that we want to return an output, we have to use the return keyword. So let's do the type of the output first. Okay, type of output in for temp_f should be double, because there's a degrees in Fahrenheit, right? So temp_f or double temp_f semicolon. Alright, so this is the type of output. Next step is to assign a value to temp_f. So what's the value of temperature in Fahrenheit? Okay, value of temperature in Fahrenheit is your degrees C times 9/5. Temp_f equals to 9/5 temp C times 9/5, okay, plus 32, or you can put 32.0. Okay, so this is how we assign a value to the temperature in Fahrenheit. So we take the temperature in degrees C times 9/5, or 1.4, or no, 1.8, and then plus 32. Alright, and then what do? We need to give a function an output. So we need to return it to the environment, so we need to use the return keyword, and we have a semicolon. And now this is our function, which is complete. Alright, so I commented down here what these steps are for, and you will be able to do it. So how do we do it? How do we execute the function? Well, first thing we need to do is the object declaration, which we have just done just now, and then next thing is to execute the function. So at T1 C2F, okay, so maybe we have a body temperature 36.9 degrees C. We put it to 1 decimal place, and then we close the paragraph. And then of course I want to have it in C, have it in Celsius, always put units down. Okay. Oh, why is this thing so many decimal places here? Okay, I think I forgot to do the rounding off. So let me do the rounding off. Okay, so the rounding off syntax is called math round. So let's do the math round. Okay, so how do we do it? I say temp_f equals to, so we are assigning a new value to temp_f. That's what the equal sign is. Equal sign means you assign a new value. Okay, math.round temp_f to that decimal places. Okay. Oh, forgot the semicolon. And there we go. So you see, math round blah 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 times whatever times and the decimal places. Alright, so that is how we have 98.4 degrees Fahrenheit. Great. Okay, so so I have shown you the basics of how to declare a class within a Razor web page using C# code, and then how to declare an object, and then how to execute the functions within that object or within that class. Alright, so that's all I have for you. Okay, maybe one more thing. How long is this? Yeah, one more thing I want to show you is, alright, there's a very common bug that you may face. Alright, a very common bug you may face. Let me demonstrate it to you. Okay, instead of having 9/5 temp C times 9/5, I do temp C 9/5 times temp C, and you look at the answer here, see whether it changes. Okay, all of a sudden now it's 68.9 Fahrenheit. Okay, what's going on? Okay, why is it like that? Okay, first let me demonstrate to you what the value of 9/5 is. At 9, okay, I need curly braces or braces, 9/5. Okay, if not it will throw an error. Okay, so I say 9/5. Oh, 9/5. Why does C# think that 9/5 equals to 1? Isn't 9/5 equals 1.8? Well, that's the thing with C#. You need to explicitly define the type first. If not, it will assume some of the type for you. What do I mean? Okay, when C# reads this code 9/5, okay, the number 9, it can be an integer, it can be a double, or yeah, meaning to say it can be integer or decimal number. But C# will think that 9 is an integer, which makes sense from from that perspective, right? If you didn't give any decimal places, should C# think that it's a double? So C# will think 9 is an integer. So this integer number 9 is divided by this integer number 5. And of course, maths will tell you it is 1.8. But 1.8 is not an integer. So what C# will do is it will just round down to 1. Right? It will not round up, it will round down to 1. And that's why you will have the number 1. Okay, so let's try and fix this. How about we use the 9.0 so that C# doesn't think that 9 is an integer. When we save this, what happens? This thing becomes 1.8. So it's very important to see what your first number is, so that C# will know how to treat the mathematics, right? So so 9.0 is definitely a decimal number, and that decimal number can be divided by integer number or can be divided by another decimal number. But the moment you introduce C#, I mean, it's the first thing that C# sees is a 9.0. Okay, once you show that it's a decimal number, C# will do math in a way that is fitting for a decimal number, and is not the way for integers, right? If C# does math with using the integer method, then you will find that we have this problem that 9/5 equals 1. So do make sure that whenever you start your when you assign a value to a variable, for example, and then you're supposed to use it to compute math, your first number here is very important, as that will decide how C# interprets this, whether this 9 is an integer or this 9 is a double. So to prevent any ambiguity, so that C# will always know it's a decimal number, I like to put a 0.0 here, so that it's clear to me and it's clear to C# that all of these we are dealing with, these are decimal numbers. So let's save, and we have the thing revert back to 98.4f, and that's the proper way of doing things. Alright, so I will of course save this to Git, but I won't show you anymore because I assume you're very familiar with it. Thanks for watching. I'll see you again.